Example 6, one last ellipse to graph here. We know it's an ellipse because each variable is being squared and we got a plus sign in the middle. So what we're going to do is we're going to take a look at the center. Remember that the h is always by the x here. So this is a little bit of a trick question because the y appears first and the x appears next. If you want to, you can rewrite this as x minus 2 quantity squared over 49. Of course, this term has to stay the same. These numbers won't switch or anything. If the 49 is under the x, it'll stay under the x. And this could be y plus 3 quantity squared over 4 is equal to 1. Whichever way you look at this, the center is definitely at 2, negative 3. If you look at the original, the opposite of negative 2 is 2, and that's the x value, and then the y value is the opposite of 3. Which is right there. So it doesn't really matter. I mean, if you want to write it like this, you can. But if you want to go right from this step, that's okay as well. We got to figure out A, B, and C. Doesn't matter where A is or B is. I mean, it does when we graph it, but A is always the bigger one. So it doesn't matter if it's here on the left, here on the right, or here on the right, here on the left. It's just A squared is the biggest one you see there, and this one is going to be 7 if you take the square root of 49. B then would be 2. And C, all we need to do is take the larger value, subtract the smaller one. So we've got 49 minus 4, which I think should be the square root of 45. And last time I checked, that would be 3 root 5. So if we're graphing this thing, we could go to 2 and then negative 3. Now, where A is does definitely affect which direction the major axis is. So we can see that it's underneath the x, either one, doesn't matter, it's underneath the x. So the major axis is definitely going to be horizontal. We need to go right 7 and left 7 from this point. So if we go right 7 from 2, that should put us out here at 9. So this point is going to be 9 comma negative 3. The y value does not change from the center. The x value will add 7 to that, so we've got 9 negative 3. And then we'll take 2 minus 7, which would give us 1, 2, 3, 4, 5, negative 5, and then we'll plot our point right here, and that would be negative 5 and negative 3. The foci appear to be at 3 root 5. And for the foci, which will be somewhere in here, to actually plot these, it's going to really help us if we can figure out maybe an approximation on our calculator. So we can take our calculator and we can take 2 and we can both add 3 root 5 and if you do just second enter, you can go right to your entry. We're going to do 2 minus 3 root 5. And we'll see what that gives us. So about 8.7. So for this one, it's going to be really, really, really close. Looks like it's going to be super close to the vertice right here, the vertex. And the negative 4.7 is going to be, again, very, very close. And this actually looks like it's negative 4, but because my Sharpie is, well, not fine-tipped, we'll just have to draw it real super close here. So those will be the foci. And if you wanted to, you could label them as being 2 plus 3 root 5, comma, negative 3. These are the exact values. 2 minus 3 root 5, comma, negative 3. And that's going to be the one over there. Okay, so now we've got those. We need to get our minor axis vertices. We just go up 2. So up 2 would be right here, and then down 2 would be right here. If we label those, this would be 2, comma, negative 1. X value stays the same. And all we need to do is add 2 to that. And so, let's see here. Oh, 2 to the negative 3, so that's negative 1, so where the negative 1 comes from. And then we've got 2, comma, and then we're going to take negative 3 minus 2, so that's negative 5. When we draw this then, we can draw this one. It looks like it's pretty stretched out. And that'll happen when your foci are close to the ends or the vertices. So this is what it looks like. And if you wanted to label those as foci, maybe the center here, of course the other ones are vertices, and draw a line kind of looking like that, that would be great. We've really done everything that the problem asks us to do. We've graphed the thing, we've labeled the center, the foci, and all the vertices. All done, finished.